So revise with me video on compound increase and decrease. So question 1 is that Alfred invests £3,500 for 2 years at 1.5% per annum compound interest. Calculate the value of his investment at the end of the 2 years. Give your answer correct to the nearest penny. So with this, he had 100% of his money, which was 3,500. And each year that goes up by 1.5% because interest is where you earn money. So if he had 100%, add the 1.5%, that would give him 101.5% each year. So that as a decimal, because we like working with decimals in compound interest, is 1.015. So I would take this 3,500. And because I want to increase it by 1.015, I need to times it by 1.015. And I need to do this for 2 years. So the long method would be to calculate it 1 year, add it on, calculate the next year, add it on again. But a calculator method is to square it. So you're going to need a calculator. So go 3,500 times 1.015 to the power of 2 should leave you with 3,605.79 pence to the nearest penny. So just if you put all of that in your calculator, it will give you that. Next question. So Grace invests £8,240 for 2 years at 3% per annum compound interest. Find the compound interest earned in the 2 years. So we've got to give our answer to the nearest penny again. So again, if she had 100% of her money, which is 8,240, each year is going up by 3%. So at the end of the year, she's going to have 103%. So again, as a decimal, because we change them into decimals, a multiplier is just easier. You can leave it as a percentage. So 1.03. So I'm going to take that 8,240 and I'm going to times it by the 1.03, because on my calculator that'll give me the answer where the 3% is added on. And because we're doing it for 2 years, I'm going to do that to the power of 2. So when I put all of that in my calculator, I should get £8,741.82, correct to the nearest penny. So it makes sense because it's gone increased from the 8,240 to the 8,741.82. So she's earned money on that investment. Next one. Illyri invests £3,700 for 3 years at 2% per annum compound interest. So we've got to calculate the value of her investment at the end of the 3 years. So again, always start with that 100% of her money. So it's add in interest of 2% each year. So therefore she'll be left with 102% each year. So that's 1.02 as a decimal. So I'm going to take that £3,700. I'm going to multiply it by the 1.02. And because this is 3 years, I'm going to do it to the power of 3 this time. And when I put that in my calculator, I should get £3,926.47. Alright, next one. So a company is set up with 500 workers. At the end of each of the first 3 years, the company employed more workers. The number of additional workers employed each year was equal to 2/5 of the number of workers that were there at the start of that year. How many people worked for the company in the 4th year? So I'm assuming they mean the end of the 4th year, so we'll include that as well. So 2/5, we know that is equal to 40%. So they had that 100%, 500 workers, and they increase it by 40% each year. So that leaves them with 140% each year. So if that's 1.4. So we know that we've got 500 workers, and we're going to times that by the 1.4, so it's increasing, and I'm assuming it's going to be the end of 4 years, so I'm going to put that to the power of 4, and that should give us 1,921 workers. Next question, we've got to calculate the percentage increase in the number of workers from the first year to the fourth year. So in the first year it had 500, and in the fourth year it had 1,921. So to calculate percentage increase or decrease, you take the change, so what is the difference between those numbers, and you divide it by the original value. So I want the difference between those, so if I take those two away, I'll get my change, which is 1421, and then to get my percentage increase, I'm going to take that 1421 and divide it by the original value, which was 500. So if I divide that by 500 on my calculator, I end up with 2.841, but that's obviously not a percentage, so if I times that by 100, I'll get a percentage, which is 284.2%. Oh, sorry, that's a 2. Right, next one. So each year, Enrico's car loses 12% of its value at the start of that year. So the car was worth 17,000 when it was new. What is the value after 3 years? Give your answer correct to the nearest £100. So this is decreasing in value. So the car was 100% of its value, but each year it loses, so I'm taking away 12% of its value. So it's actually only left at the end of each year, it's only got 88% value. So I'm going to do the same like we always done. So changing that to a decimal, 0.88. So I'm going to take the car's worth, the 17,000, I'm going to times it by the 0.88, and it's over 3 years, so I'm going to do that to the power of 3. So when I put that in my calculator, I get £11,585 and 2 pence, but they want it correct to the nearest £100, which is £11,600. So it loses quite a bit of value after the 3 years. Last one. So Rowena owns a car that David is planning to buy in 3 years' time. So the car is currently worth 3,500. They estimate the car will repeatedly depreciate by 24%. So depreciate means it loses value each year. So they expect it to lose 24% of its value each year. So David has already saved £100. He wants to set up a savings account to save a fixed amount of money each month to buy the car in 3 years' time. We need to work out the minimum amount of money to the nearest pound that he should put into his savings account each month. So first of all, we're going to have to calculate the cost of the car to see how much it's going to cost him. So the car was 100%, 3,500. If it loses 24% each year, that means it's only going to be 76% every year. So as a decimal, 0.76. So we're going to take the car's worth, the 3,500. We're going to times it by the 0.76. And because it's over 3 years, we're going to put that to the power of 3. So when you put that on your calculator, you get 1,536.42. So that's how much the car is worth. That's how much he expects to pay for it. Now he's already saved £100. So he needs to save. So he's got the 1,536.42, the cost of the car. We take off his £100 he's already got. That leaves me with 1,436.42. So he needs to save that much money. Now he's got 3 years. So he's got 3 years, and we need it in months. So I know that 12 months in a year. So in 3 years, there's going to be 36 months. So to find out how much he needs to save, so we're just going to take away the 43642, and we're going to divide that by the 36 months so we can have equal monthly instalments. So if I do that on my calculator, I end up with £39.90. They did say they wanted it to the nearest pound, So I'm going to round that up to £40. So he needs to save £40 each month. There is a part B to this question. So, do you think this amount saved each month will guarantee that he will have enough money to buy the car? You must give a reason for your answer. So if I just briefly go back over the question. So it's currently worth $3,500. He estimates that the car will repeatedly depreciate by 24%. Now, straight away, he's only estimated, so he can't guarantee that he'll get the car because he's only estimated. So if I was to write that, I would say no. So as he only estimated the depreciation, if the estimate is wrong, he would need more money. You could also say that because he's investing, he's saving his money, he could earn interest on that money, but it doesn't matter which way you write it. On the mark scheme, I think they've said. So conclusions stated or implied with suitable reason. So yes, because he might get interest on his money, so he needs more, or no, because she only estimated the value. So don't know because Roe may decide to sell it more or less than its value after depreciation. So anything along those lines is fine. Okay. If you want any other topics, just let me know.